This video will be about patterns. Most patterns are a list of numbers that are related somehow. They could be adding the same number every time, multiplying, dividing. There's lots of ways to make up a pattern, but most often if you check addition and multiplication, one of those two will be what your pattern is. So usually when you're looking at the pattern, we have 2, 8, 14, 20. Usually it's best to start with a. So to get from 2 to 8, you have to add 6. Then we check the next one to get from 8 to 14. We're adding 6 again. So once things start matching, that's how we know we have a pattern. Each of these times we added 6. So if the same pattern continues, if we continue to add 6, what is the 8th term? So we had a first term, second, third, and fourth. We need to add 6 4 more times. So the 5th term, if we add 6 to 20, would be 26. The 6th term, if we add 6 to 26, would be 32. 7th term will be 38, and 8th term will be 44. So let's look at the next pattern. Let's try addition again. So to get from a -3 to a +6, we have to add 9. But to get from a +6 to a -12, we have to minus this time. We'd have to minus 18. So that's not a pattern. We are not matching. So we need to start over. So addition didn't work. Let's try multiplication. To get from a -3 to a +6 using multiplication, we'd have to have a negative number because a negative times a negative makes a positive. And then 3 times 2 makes 6. So -3 times -2 makes the +6. Then we try again. To get from 6 to -12, we're multiplying. A positive times a negative makes a negative, so negative again, and then 6 times 2 is 12. So we can check the last one just to be sure. -12 times -2 does make the 24. So our pattern is to multiply by -2. This time we want the 10th term. So we have 4 terms to start with again. Our 5th term, 24 times -2, is -48. -48 times -2 is +96. +96 times -2 is -192. -192 times -2 is +384. +384 times -2 is -768. And then I'm going to have to write the 10th term below. -768 times -2 is 1,536. So we just keep following the pattern until we get to the term we want. Sometimes they will give you patterns where they don't actually tell you the numbers, you have to figure them out. So for the first figure, it took 1 toothpick to make the figure. For the second figure, we have 1, 2, 3, 4 toothpicks to make the figure. And for the third figure, we have 1, 2, 3, 4, 5, 6, 7 toothpicks. So our pattern is 1, 4, 7. So if the pattern continues, how many toothpicks are needed to make the 7th figure? Well, once you've figured out what the actual numbers are, you do the pattern the same way. Let's try addition first. To get from 1 to 4, you have to add 3. And to get from 4 to 7, you have to add 3 again. So adding 3 is our pattern. We just have to keep going until we make it to the 7th figure. We have 3 so far, so our 4th figure, we add 3 again. 7 plus 3 is 10. 5th figure, add 3 again, we get to 13. 6th figure, we add 3 again, we get to 16. And 7th figure, add 3 again, we get to 19. So we would need 19 toothpicks for the 7th figure. Sometimes they'll give you a problem where they just tell you the pattern itself. So this problem states a colony of rabbits starts with 50 rabbits, so our very beginning is 50. If their population doubles every 3 months, how long will it take for there to be 6,400 rabbits? So we start with 50 rabbits. it says the pattern is that we're going to double. Doubling means to multiply by 2. And then we have to track the time because the question is how long. So after 3 months, we have our first doubling. 50 times 2 is 100. So after 3 months, we made it to 100 rabbits. If we times by 2 again, that would take us up to 6 months. 3 more months takes us to 6 months. So after 6 months, we have 200 rabbits. We have to keep tracking this until we get to 6,400 rabbits. So after 9 months, we will have 400 rabbits. If we do 3 more months, that takes us up to 12 months. After 12 months, 400 times 2 is 800 rabbits. 3 months will take us up to 15 months. And we're multiplying by 2 again. 800 times 2 is 1,600. Oops, I wrote 1 extra 0. We do it again, add 3 more months. We take it up to 18 months. And 1,600 times 2 is 3,200. And then we go up 3 months again. That takes us up to 21 months. And we times by 2 again. That takes us to 6,400 rabbits. So it's kind of a tedious process, but it does help to actually write it out as we go along. It's hard to track in your head the number of rabbits and the number of months. So if you just write your pattern out, it may take a little bit, but you will get to the correct answer eventually if you follow the pattern. Now sometimes they give you a pattern using a table, and when we have a pattern like this, it may not follow the addition or the multiplication. The addition or the multiplication is the easiest. So the table below shows the values for the function. The x values are stating like the figures. You know, figure 1 has -1, figure 2 has 8. It's that similar thing, they've just written it sideways, whereas most of the time the patterns only list the y values or show a picture and you have to say, okay, figure 1 is this, figure 2 is this. Now I wrote the answers for this one because notice that a lot of the answers have these squared. It's really hard to tell a pattern and figure out a pattern if it involves squaring something. So the best option with a problem like this is to actually use the answers and just check to see which one works. So the answers say f of x equals 2x minus 3. We're going to start with this one. Now f of x is a fancy way to say y. This is just saying your y value you get when you plug in x. So we're going to check by plugging in the x values and seeing if we get the correct y value. So for my first x of +1, 2 times 1 is 2, minus 3 is -1. That is the correct y value. We should check more than one though. Sometimes they will give ones that will work for 1 or 2, but maybe not the next one. So we're going to check 2. 2 times 2 minus 3 is 4 minus 3, which is +1. That did not work. We should have gotten an 8. That means A is eliminated. I'm going to erase all this so that when we check the second one, it's not overlapping anywhere. So let's try answer choice B. We're going to replace with the +1 first. 1 squared minus 2. 1 squared means do 1 times 1, which is 1, minus 2 is -1. Again, it worked for the first one. Let's double check another value. So 2 squared minus 2 is 2 times 2 minus 2, or 4 minus 2, which is 2. That is the wrong value. We should have come out with +8. So again, I'm going to erase this work. We know B does not work. Let's try C. So C states 3x squared minus 4. So we're going to plug in 1 first. 3 times 1 squared minus 4. 1 squared meant 1 times 1, and 1 times 1 is 1. 3 minus 1 is, 3 multiplied by 1 is 3, and 3 minus 4 is negative 1. So again, it worked for the first one. Let's check when we plug in 2. If we do 3 times 2 squared minus 4, so we're always replacing that letter x with the number we want to check. 2 squared is 4, 3 times 4 is 12, and 12 minus 4 is 8. That one worked. So our answer is most likely C. If you just want to make sure, you can always check D, or you could check by plugging in 3 and 4 to make sure those also work. So I'm going to check D just to make sure that C is the correct answer. So answer choice D said 5x squared minus 1. We're going to replace with 1 first. 5 times 1 squared. 1 squared is 1. 5 times 1 is 5. And 5 minus 1 is 4. Should have come out a negative 1. That one did not work, so it's definitely not D. So now we've confirmed that for sure the answer is C. So this concludes our discussion on patterns.